intensity, sound intensity changes with distance from point of source. So if we look at the equation to describe the intensity of the sound, I is given by the equation. Intensity I is given by the equation power divided by area A. So the here area A here is referred to the pi r square. So meaning here intensity because the question asks you about the distance is referred to the radius here or distance is inversely proportional to the area or inversely proportional to the 1 over r square. Continue to the question number 2. A longitudinal wave, horizontal spring coil move back and forth in a directions wave motion. If the coil speed increase, does the wave propagation speed decrease, remain the same, or increase? Explain your answer. So if you look at the wave speed v is frequency times lambda. So meaning here the speed is related to the frequency and the lambda. So here is your if the coil speed is increased, so meaning here the v is remain the same because of v or the speed does not depend on the coil speed. Right? Continue to the question number B. A progressive transverse wave traveling a wire have amplitude 0.2 mm and frequency 500 with a speed 196 meter per second. So question number 1 asks you to write displacement equation. For progressive transverse wave, general equation is y in function xt is equal to amplitude A sine omega t plus minus kx. To calculate or to find the equation here, so you must know the value of the omega, angular frequency, amplitude, and k.
It's 8
So
o'clock.
if you look at the equation here, the amplitude is 0.2. 0.2 millimeter is times 10 power of minus 3 meter convert to the SI unit. And what happened to the omega? So to calculate the omega here, because omega is equal to 2 pi over t or 2 pi times frequency. Because the question gives you the value of the frequency, so meaning here you can find the value of the omega because the frequency is 500. So here we have a value of omega is 3142 radian per second. Okay, so next is what is k? So k, as you know, is a wave number is equal to 2 pi over lambda, right? So here to calculate the value of the k, because the equation give you the value of the v, because v is equal to f lambda, so meaning here k is equal to, or k, right? We continue, k is equal to omega divided by, this is omega divided by v. So here we have a omega is a 3142 and the speed is given 9196. So the k is equal to 16 radian per meter. So now you have the value of the k and the value of omega. So now you can write the equation, displacement equation, y equal in function xt, the amplitude is 002 power of minus 2. This is okay, you can use the 0.2 times, this is amplitude, sorry, this is a millimeter, this is minus 3, right? Sorry, minus 3 Okay, sine omega is equal to 3142 t plus or minus. So you can use the both plus or minus because the question not give you the direction. It's plus direction to the left to the right, and for the for the plus direction to the right, and negative refer to the direction to the right. So if you use the negative here, so we have k here. This is a 16x. So this is the equation. Continue to the question number 2. B2 is the if the mass per unit length a wire 4.1 gram per meter, calculate tension of the string. So you know we have an equation to calculate the V, the speed is given by the equation tension of the string divided by nu. Nu is a mass per unit length, right? So here to calculate the tension T here, this is T is equal to V square times nu, right? Times nu. And now you can use the equation. The V is 196, and the nu is mass per unit length. Mass per unit length. This is 4.1. This is gram, so you must convert to the kilogram times 10 power of minus 3. So now you can find the value of the tension is 157.5 Newton. Continue to the number C. This is related to the Doppler effect equation. So submarine travel in water with speed 8 meter per second, emit sonar, the frequency 1400 Hz, approach to another stationary submarine, given the speeds in the water, sound is 1530 meter per second. Calculate apparent frequency. So here let's say this is a submarine 1, okay, and this is submarine 2. Let's say this is B and this is A, and the submarine A emit the sonar. This is sound wave, sonar, and the direction of the submarine A is to approach to the approaching to the submarine B, and the submarine B is a stationary. So stationary meaning V is equal to 0. So the frequency or apparent frequency detected by observer, let's say we have observer in the submarine B, so meaning here the sound of the or the frequency reached to the observer is or F not this is apparent frequency detected by the observer, and this is frequency of the source produced by the submarine A. So according to the Doppler effect equation, so we have a frequency detected by the observer is equal to speed of sound, this is in the water, plus minus V of the observer, speed observer, and divided by speed of sound in water, plus minus speed of the source, and time frequency produced by the source. Right. So now here, because the observer is stationary, so meaning this is equal to 0, and the V is a constant 1530 meter per second, and also we have speed in the water is 1530. So the problem here is Vs. Here Vs, the speed of the submarine is 8 meter per the speed of submarine is 8 meter per second. The problem here, this is a plus or minus, because when the the sonar wave produced by the submarine and approaching to the submarine or observer, so meaning the frequency is increase, right? So now here, and the frequency source is given by the value magnitude 1400. So meaning here, to increase the value of the frequency reached to the observer, so you must use the value negative here. So now 1530 minus 8. So you can use the calculator and you can find the final answer for the question number C. The frequency, apparent frequency detected by observer is equal to 1407 Hz.